Hi everyone. In today's challenge, we have a problem. The problem name is check completeness of binary tree and the problem number is 958. Alright. So guys, first of all, we are going to clearly understand what this problem says, what actually we have to do in this problem. After that, we are going to move to the logic part. We're going to see how we can solve this particular problem, what should be the logic. And after that, we're going to move to the implementation part. We're going to implement our logic in C++, Java and Python programming language. Fine. Now let's see what this problem says, right? So this problem says given the root of a binary tree, so we are given the root of binary tree, determine if it is a complete binary tree or not. All right. So one thing is clear that we are given the binary tree, right? So that is a binary tree. It might have a left node and right node, right? And after that, we have to check whether it is a complete binary tree or not, right? So now, guys, if you don't know about complete binary tree, so let me tell you what is complete binary tree. So let us assume that this is a tree, right? So guys, a tree can have left and right node. So let's assume this is a tree. So guys, if a tree has n level, right? So I hope you know level. So this is level 1, this is level 2, this is level 3, right? So if tree has n level, n minus level minus 1 level should be completely filled. First of all, it should be the point, right? So n minus level 1 level should be completely filled all this level. So if I make one more level, there is a 3, so you will not have better idea. So let's make it 4 level tree. So here you can see that this is a 4 level binary tree, right? So 4 level, that means n minus 1 is 3. 1 to 3 level, 1, 2 and 3. These 3 levels should be completely filled. That is a one point. Second point, the last level may be incomplete. It should not be completely filled, but it should be filled from left to right side. So now guys, let's see example. This is a complete binary tree. I hope you are getting it. But if I remove this particular node, then also it is a complete binary tree because its last level is incomplete, but left to right node is the nodes are filling from left to right node, right? If I make this is also a complete binary tree, right? It is a full perfect binary tree. But guys, if I don't remove these things and if I say, is it a complete binary tree? No, it is not a complete binary tree because the last node levels are not filling from left to right side, right? It has filled this particular part, then you have filled this particular part, but this in between you have empty nodes, right? So this is not a complete binary tree. And if I just say, okay, remove these things, just make it here only, and remove this node, right? If I remove this particular node, this has only one node, not right node. So will it be a complete binary tree? No, because the last it was 4 level binary tree, and first level is completely filled. We have one node. Second level is completely filled. We have two node. Third level should have four node because there are 4 levels. So third level also should be completely filled. It should have 4 node, but there is a 3 node, right? So it is not a complete binary tree. I hope guys now by this example, or we can say by this statement, you have a clear idea. All the levels should be completely filled except the last level, and last level should be filled from left to right side, right? So now let's see the examples and understand this problem. So let me remove all these things. So in example, you can see that we are given the binary tree, right? Now guys, can you tell me this is a complete binary tree or not? You can see that there are 3 level only. The first level has 1 node, second level has 2 node, and third level should have 4 node, right? But third level we are having only 3 node, right? But it is the last level, right? And last level you can see nodes are filling from left to right side. So we can say all the levels n minus 1 levels are completely filled, and the last level is incomplete, but they are filling from left to right side. So it is a complete binary tree. So it's gonna return 2. But here if you focus on example 2, you can see guys, this is 3 level, 1 level, second level and third level, right? And we have already covered this example as well. So the first level is completely filled, second level is completely filled, third level is not completely filled, but it is a last level. It could be incomplete, but the node should be filled from left to right side. So it is filled, and here it is unfilled, right? So that means it should not be the case, right? If there is a node, then it should be come on the left side, then right side, right? So you can see that this is an incomplete part which we have left in the last third level. So it is going to be, we can say, not a complete binary tree. It is incomplete binary tree. So we are going to return false. You can see in the output as well, we have false. So now guys, by this example, you must understood the problem. So it was totally about to understand the problem. Now let's see the logic part, how we can solve this particular problem, right? So the logic is going to be really very easy. We are not going to spend much time on the logic part. So what is the logic? Let's say I have this binary tree. All right. So if I assume these things, and if I make little more, all right, so let's assume this is binary tree we have right now. So guys, what we are going to do, we are going to just do nothing. We are going to use a breadth first search. You can use a DFS as well, but here in this we can say logic part, we are going to use a BFS, breadth first search. So what is going to do, it's going to traverse level by level. So firstly we're going to have this level, then we're going to have this level, then we're going to have this level, then we're going to have this level, right? So what we are going to do, we are going to completely fill on the level, right? So we are going to say if we are initially our BFS, we can say it's usually use a queue. So we have nothing but root. All right, so we are going to have a root, and after that we are going to put all the root left side and right side. So then it's going to come, let's say this is 1, this is 2, this is 3. Assume this thing that there is a value node 5, 6, 7, 8, 9, 10, 11, right? So now this is going to be very easy for you if you assume this thing. Initially we have in 1, right? Then on the next level what we are going to have, we are going to have 2 and 3 because 1 has 2 and 3 left node. Then after that, what you're gonna have? You're gonna have 4, then 5 and 6. Let me put comma, and then 7, right? Because it's gonna insert from left to right side. First you're gonna take left node, then right node, right? And the next level, what you're gonna have? You're gonna have 4. I'm sorry, 4, 8. You're gonna have 8, then 9, 10, then 11, right? So you can see that, and after that node 11, it's gonna have we can say null, then null, right? Because it does not have any left and right node. 7 also has, so it's gonna have 4 null node, right? So guys, you can see that we got these 4 levels, right, by using a breadth first search. So we are traversing over it and we are getting that first time null, right? So we can say this is going to be a complete binary. If we found first time null, then after everything is null. I hope we are getting it. If this is null, no issue. But there should not be any other nodes after that. I hope you are getting it. If I remove these things, then you will get a better idea. If I just say, okay, just take one node here. 7 has left node. That is, let's assume it 12. Let's say 13. Yeah, or it. I could take it 15. So let me write here just nothing but with a different color, blue color. Let's say 14, right? 11, 12, 13, and 14. All right. So guys, what I'm saying by this that if I just use a 14, then what I can do? I'm gonna say 6 has no node, so null null, but 7 has one node, that is 14, right? So I can assume it has right node, that is nothing but 14, or it's have a left node, that is nothing but 14, right? So now I'm having this particular thing at the last level, and if you can see that first time I got null, then second time I got null, but third time I'm having a value. This should not be the case in a perfect binary tree. If you're getting first time null, then all the nodes should be the null on the right side, right? Or we can say on the next level. So it should be null, null, null. But here we have value, so it is not going to be complete binary tree, right? And same thing if you are just removing this 6 part as well. Of if I say 7 part, and just you are taking this 12 here. So let me take a same color. So you can say this is going to have left and right node. That's nothing but 12 and 13. Fine. So what it gonna do? It gonna say it gonna make our binary tree like this. So we have nothing but 1 on the first level, then 2 and 3, then 4, 5 and 6. We are not having a 7. It's we are having, instead of that we are having a null, right? So I can say we are having a null. And after that we are going to say 4. It's having a 8 and 9 side. 5 having a 10 and 11. 6 having a let me remove all these things. 6 having nothing but 12 and 13. And 7 is not there, so it's gonna not fill anything. But guys, can you see that once we got a null, we should not have any other nodes. I hope you are getting it. Once you got a null, you should not have any other nodes. But here there are 6 nodes exist. So it is also not a complete binary. So by this BFS, we can easily estimate or we can easily identify whether it's a complete binary or not. Once you go to null, you should not have any other node exist after that. If you go to a null, and all other nodes which are going to become, it should be a null. Otherwise, it is not a complete binary. So now let's move to the implementation parts. We have a lot of discussion. We have done a lot of discussion about this BFS. So what we are going to do, we are going to use the first programming language, that is Python. Then we will move to the C++, then Java, right? So how you can use a BFS? Just you have to maintain a queue. So I can say queue, which is I'm going to use a collections dot tq, and here I'm going to pass a root. And they have mentioned in you can see, I would say that just focus on constraint. They have mentioned that there will be at least one node, right? So I don't need to take care about if root is null or not. So there is at least one node. Now I'm going to say while queue exists. All right, so I can say that take out the first node. So I can say okay, I'll give it a name q, more easy. Q dot pop left, take out the first node. Once it took a front node, then we're going to check if it is null. If it is null, right? If it is null, so we can say if not node. If it is a null node, then we can say okay, we found a node. So I can make one thing, that is flag. So I can flag, which is initially what it could be. It could be initially false. That means we haven't encountered any null node. But if we encounter null node, so we're going to say flag is equal to, let me write a flag is equal to true. Fine. And if it is not a null node, right, then we have to check it whether we have already encountered null node or not. So if we have encountered already null node, that means if flag is true, that means it says that we have already encountered null node. It should not be the case, right? So if we have already encountered a null node, then we can say it's not a complete binary, right? Because after null node we are getting a node, right? So we can say return directly false. But if it's not the case, then you can say q dot append node left side and q dot append node right side. I hope this making a sense, right? So once this is done, so we are gonna return true, because once we come off from this while loop, that means we haven't encountered these conditions. If flag is equal to true and return false, that means it is a complete binary, right? So we can return it. So let's try to run this code and see whether it's getting submitted or not. First of all, let's see the test case. So here it's taking a time. Okay, maybe my internet connection is not good, so let me just give it a refreshments, right? So fine, let me refresh the page, or let me check it whether I have internet connection. All right, so it's the case, right? Let refresh it. Okay, Yeah, it was an internet issue, right? So it's taking a lot of time. So now let's see. Now let's run this code and see whether it's working fine or not. Okay, let's code should be come display. Right here we got an error that is nothing but we got an error that is solutions is incomplete. Let's try to run this again because code was not just loaded there, right? Now you can see that both test cases are passed. So let's try to submit this code. And yeah, internet issues sometimes make you really, I know how it feels when internet goes. So we have successfully submitted this particular, we can say code with the Python. We have solved our problem with the Python. Now let's move to the next programming language that is nothing but C++. All right. So in C++, what we are going to do, we are going to say, I'm going to maintain a queue. So I can say, I'm saying the queue. So let me give a queue and it's going to be a tree node. Fine. And it's going to be nothing but I can say queue, right? And inside of queue I'm going to push my load. Okay, and what I'm going to say, I'm going to say while queue is exit, queue is not empty, right? So I can say while queue empty is false. So what we're going to say, we're going to say nothing but we're going to say take out the first node. So I'm going to say tree node, a node is going to be nothing but q dot front and q dot pop, right? Once this is done, we are going to check it. If node is equal to null ptr, that means we have encountered a first null node, so we're going to make flag is equal to true, right? And else we're going to check it if flag is already true. And how you can counter a node if it is a complete binary, right? So it is not a complete binary, return false. Otherwise you can say q dot push. What we can push left side and right side. So we can say node left side and we can say node right side. Fine. And once we are done this thing, we are going to also make a flag variable here. So flag is going to be nothing but bool flag. Flag initially is nothing but false. So we can return our true once we come out from this while loop. We have already discussed. All right. So now let's run this code. And you can see that both the test cases are passed. So let's submit this code as well. And I believe it will get submitted, right? So we have seen that, and here yes, we can see that it successfully got submitted and it's beat 100% fine. So now let's move to the Java programming language and see what's how we can do this thing. And let's make a first of all queue. So we can make a queue. All right. So queue is gonna take an data type tree node. Fine. So we can say queue of like tree node. We can say, and the name I'm gonna give queue is in nothing but let's give it a linked list, or we can say a priority queue, right? So it could be a linked list here. Fine, linked list. All right. So here what I can say, I can say queue dot add root first of all. Now you can use a while condition. Before that, let me make a variable. So we can say boolean. I can say flag is going to be initially false, and while, so we can say while queue exists, right? So queue dot is empty is false. Means like at least there is a single one node exit in our queue. So what we're gonna see, we're gonna check it. First of all, we're gonna take out the first node. So I can say node queue. I can give it a tree node. I can say node and queue dot. I can say poll, right? Once this is done, we're gonna check it. If node is null, then you can say flag should be false, right? So flag should be true. It should become true, and else we can say check it. If flag is already true, that means it is not a complete binary, so return false. But otherwise, you can say q dot append. Not append here. You can say q dot add, and what you are going to add, you're going to add the left side, and you're going to add the right side as well. So I could say q dot add node dot write, right? So let me write a q dot add node dot write. Once this is also done, so we are going to come out from the loop and we're going to check return true, because once we are come out from the loop, that means it is a complete binary tree. So let's try to run this code and see whether we are getting any error or not in Java. And here you can see both the test cases are passed. So let's try to submit this code. And by this, if it got submitted, by this we have completed, you can see also it got submitted, right? So by this we have completed our logic implementation C++, Java and Python. If you still have any kind of doubt, you can ask in the comment section. I'm always there to help you. If you learn something new in this video, don't forget to hit the like button and subscribe my channel. Meet you in the next video.